So we're starting with our new chapter, which is about max, intro to polynomial functions. One variable, right, which has 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 one variable, right, which is expressed to this form where a are polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at the polynomial functions, and then we're going to look at their end behavior polynomial functions, and then we're going to look at their end behavior, their domain and range, and the turning points that they have. So this is basically kind of an inquiry that you guys can do, but we're going to do it together. Function. That linear function. That linear function. How many turning points do we have? 0. Is there an absolute max or min? No. And then the end behavior as x approaches infinity, y is approaching infinity, and then as x approaches negative infinity, y approaches negative infinity. Polynomial functions. If I have now, what happens if I have f of x equals to negative x? 1 for what's the degree? Degree 1, the degree. Degree 1, the degree. Degree 1, increasing or decreasing? Decreasing. So it's going to be a linear function going through the origin. Sorry guys, this is supposed to go through the origin. Just this is the best I can do here. Okay, then this is the origin. What's the domain? And the range. No turning points. And no max local max or min. How about the end behavior? What happens when x approaches negative infinity? Where does y approach? Right? You look right here, as x approaches negative infinity, y is approaching positive infinity because it's decreasing. And as x approaches infinity, y approaches negative. Moving to x squared. quadratic function. And as you know, it has a parabolic shape. What would be the range of this one? That's right. So in this case, you have to be careful. It's you have restriction on the y, where y is greater than or equal to 0 because of your vertex. So your vertex, your optimal value starts at 0 going up. And why is it opening up? 1. 1. Is there an absolute max or an absolute what? Min. Absolute what? Min. And then what's your end behavior? As x approaches negative infinity, what does y approach? Infinity. And as x approaches infinity, y approaches infinity. Are you guys? Negative x squared, it has a degree of 2. How would the graph look like? Opening down, it's a parabola opening down, because the leading coefficient is negative. Domain is XCR. And the range is, what's the range? Less than or equal to 0. Absolute what? Max. At the vertex, I have an absolute max. And then my end behavior as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches negative. All right, moving on to, can you guys see this clearly? But can you see it on your graph? Yeah. Okay, 3. So that's 3. So that's 3. So that's a cubic function, right? What's the all real number? How about the range? Yeah. So as you can see, if you look at the y, right? If you look here, the y starts from negative infinity and then goes all the way up to positive infinity, right? So there's no rest 2. So there's one right here, 2. So there's one right here, 2. So there's one right here. There's one as a local local max, and there is one as a local min. Is there any absolute max or min? No. And behavior as x approaches negative infinity, what's happening to y? It's negative infinity, so we see that's right there. And then as x approaches positive infinity, what's happening to y? That's correct. Now, the leading coefficient here is positive 3, right? I'm just going to put positive here. Degree 3. Degree 3. Degree 3. Degree 3. Degree. Degree 3. Leading coefficient. It's a negative, right? So it's a negative 3. Domain. Domain. All real numbers. Range is all real numbers. Again, this is one of the cases where you start from positive infinity. Turning points, I can see. Turning points, I can see 2. Does it have any absolute max or min? No. And as x approaches negative infinity, y approaches infinity. And then as x approaches positive infinity, y approaches negative infinity. You should start seeing some trend as we go on. Degree. 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 4. Leading coefficient positive or negative? It's positive. What's your domain? X. X, element of the reals. How about the range? Does it have a range? Does it have a restriction on the range? Sorry. It's right here. Just, it's right here, right? So anything greater than this point. Okay, so it's going to be y, element of the real, where y, and don't ask, I graphed it on Desmos so I can get this point, where y is greater than or equal to, okay, you must put that equal, negative 0.782. Yes. I told you I graphed it on Desmos, okay? 3. So y, 3. So y, 3. So 1, 2, and 3. Is there an absolute max or min? Where? The min. That's right. So you see this one right here, which is y equals to negative 0.782. That's your absolute min. Behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity. So the end behavior is as x approaches infinity, or negative infinity, sorry. Y approaches infinity. And as x approaches positive infinity, y approaches positive infinity. Y doesn't have y, right? And then with the min, you're going to look at the lowest point on the graph. And then with the min, you're going to look at the lowest point on the graph. And then with the min, you're going to look at the lowest point on the graph. And then with the min, you're going to look at the lowest point on the graph. And then with the min, you're going to look at the lowest point on the graph. And then with the min, you're going to look at the lowest point on the graph. And then you're going to say, this is my absolute min. The graph for the next one is incorrect. This graph right here is incorrect. This. I'm gonna try my best. So kind of like flipped to what you guys see. Mirror image of it. All right. So that's a degree 4 again. Is the leading coefficient positive or negative? Yeah. It's -5, right? It's XCR. That's the domain. And the range is, what's the range? Less than or equal to 8.1. How many turning points do you have? Absolute max or absolute min? And the end behavior the degree 5 leading coefficient is positive. What's my domain and range? Do I have any restriction on the range? No. Again, you see that the range is going all the way from -infinity to positive infinity, so there's no restriction. How many turning points do you see? 4. Is there any absolute max or min? No, there is none. No, there is none. Remember, because your y value, and then behavior as x approaches negative, and then behavior as x approaches negative. And then behavior as x approaches -infinity, y is going to approach -infinity. And then as x approaches positive infinity, y is going to approach positive infinity. Have you seen a trend yet or no? Okay, how about on the following graph? Domain? You can't see it on your paper? It's kind of, I can't go over it because it's gonna be bad. Huh? Okay, what's your, I think so. Okay, what's your domain and range, sorry. Same, XER, YER, it doesn't change, right? Again, you're starting from positive infinity going all the way down to negative infinity. How many turning points do I have? 4. They're very close, and then you determine, but there's 4. Do you have any absolute max or min? No. And then as x approaches infinity, or negative infinity, I should say, y approaches infinity. And as x approaches infinity, y approaches negative infinity. Okay? 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 So for the next equation, what is my degree? 6. 6. And positive leading coefficient. So at 5, I'm going to have my minimum, and it's going to look like this. Why is it at 5? Because I can put it, this is how it works out. You can put it, sorry, let me just put it in. Oops, wrong one. That's not to the power of 2. Any even degree function or even function can have the same shape as a quadratic function if it doesn't have any turning points or if it doesn't have any zeros. Okay, so that's why in this case it's looking like a quadratic function, but it's not actually a quadratic function. It's to the power of 6. But I'm gonna show you. So in this case, how many turning points do you see? I only saw 1. I don't know how you, so let's just write it down. It can be anything less than that. So it can be the degree minus 1 or less. So you can have 5 turning points, 4 turning points, 3 turning points, 2 turning points, or 1. Yeah. Okay. We'll look at this rule in a bit. Here's a function. Can you guys see it? So as you can see, this function only has 1 turning point. It doesn't have any zeros. It looks like it's a quadratic function, but it is not. Okay? No. No. How would you know? You won't be able to know that unless you factor it and then you find your zeros. Okay? And try to graph it. In this case, what I just did, as I said, I just plugged it into decimals and I found my graph. But later we're going to learn how to graph these things, and then we're going to do factoring and then graphing. Okay? Can you guys tell me what's the domain for this? Tell me what's the domain for this. Yep. How about the range? How many turning points? Absolute max or min? Min at y equals 5. And behavior I'm going to take you back to decimal so we can graph the next one. So y equals negative 4x to the power of 6 plus 7 and minus 3x cubed and plus 4. All right. So here's how the function look like. I'm gonna have to kind of zoom in a little bit to see how many turning points we have. Okay, so we have one on the top, and we all know that, right? I'm not gonna scroll up, but as you can see right here, it looks like I have decreasing. Then it looks like it increases a little bit, then decreases, and increases. So this is what defines a turning point. A turning point is when you have something that was increasing before and then decreasing, or if it was decreasing and then it starts increasing. Okay, that's what defines a turning point. So I'm gonna zoom in here a little bit. So I'm not gonna call this a turning point, okay? Because it's a flat, well, it looks like, at least to me, it's flat, okay? However, if you see this one right here, this is a turning point, okay? Why is this a turning point? Because as you can see, it was decreasing, and then it went back up and started increasing, okay? So from what I see right here, I have one turning point on the top, I have a turning point right here, and then a third turning point right here. Okay. So I have 3 turning points. Can you guys do a quick sketch for this graph? I'll show it to you. I'll zoom it out. So if you want to do a quick sketch. I'll see if I can do a snap. If I can snap it.
Goes down into a straight line and down again.
It keeps going down. Okay. But there is a little turning point in between 0 and 1. Can I go back to the... You can always graph it on Desmos. Yes. XCR. And then range. I believe it was 11.767. To the point. Yes. I have 3 turning points. Why? Huh? So our y is less than or equal to 11.767. And then I have an absolute max at that value. And then domain and range end behavior x approaches negative infinity, y approaches negative infinity. And as x approaches infinity, y approaches negative. Let's write this down. You'll copy, okay.